In this video, we are going to expand on validating input and validating method arguments and talk about how to handle exceptions. So, validating method arguments is something you have to do to ensure that the method behaves like it was intended. There are two ways of validating method arguments. You can either do it before the method is called, or within the method itself. So public methods have to do what is called a callee validation within the method itself, because they receive arguments across trust boundaries, such as from other libraries or input from users. Other methods, including private methods, should technically speaking also validate all arguments as well, but dependent on how we've designed our system, they might trust arguments from methods within the same class, but they shouldn't always assume it is so. So you have to check where the argument came from. Is it another private method, or is it the source, both untrusted and unvalidated? Then you have to do a callee validation. Now, this is how you don't do it. You have a private attribute and then two public methods. One that sets the private attribute and the one that uses the attribute. The set method just blindly assigns the argument to the private attribute, and then the use method doesn't perform any checks. So there are a whole lot of issues that could go wrong with how this is implemented. You don't know the state of that private attribute. It's just an object, which can be basically anything, and you can set it to whatever, or it can be set as whatever. Now, instead, you should implement it like this. I know there's a whole lot of more code that you have to write, but that's the price you have to pay for security. So instead of just setting the private attribute, the set method now tests the argument first to see if it's null, and then some unspecified validation check method that you have to implement yourself. If it passes all the tests, then it is allowed to set the attribute. The use state method also needs to be able to handle different scenarios. So in this case, it checks first if the object is at its initial state, where the attribute is null, and handles that state. Otherwise, it does what it was intended for originally. Now, it's often impossible to account for every possible situation or every possible value of an argument with validation, unless nothing. It's not possible. It's often not possible. So sometimes we have to assume that there will be exceptions. Exceptions are either checked or unchecked. That is, you'll either get notified during compilation or runtime. Every programming language has its quirks and own implementations of exceptions. For example, in C++, all exceptions are unchecked, while Java implements both. Most exceptions in Java are checked exceptions. Only those that fall under errors or runtime exceptions are unchecked. Unchecked exceptions aren't so much the problem. It's the checked ones, or how we as programmers handle them sometimes. So there is a debate about catch statements. Many programmers will tell you to avoid them at all costs, but they are unavoidable. At one point or another, your program has to deal with it. It can't just throw the exception to the next level up. It's how you deal with it when you catch those exceptions that matters. Do not just suppress them and do nothing about it. So don't just catch them and then pass and act like nothing happened, print out something or whatever. Uh, the catch block must do something to recover the state of the program or rethrow the exception and allow the next and closing catch clause to recover. So again, at one point or another, your program has to deal with these exceptions. Otherwise, you'll probably end up with either a bug that's really difficult to find if you just pass on, or a vulnerability of a hard to detect intrusion. The wrong way to do it is to just handle a caught exception with some kind of print, as in this example. You can use it, and it's really helpful when debugging. Print as much as you want while debugging, while you're developing. But as soon as you've put the program into deployment, that should not be there. That print statement there should not be there. The proper way of dealing with exceptions is to handle the expected exceptions. Not to suppress them, mind you, but to allow the program to recover. Like in this case, we're trying to open a file and you allow the user to recover the process if the file isn't found without leaking any information, because that's a big security vulnerability as well. You give the user relevant feedback and not just any feedback. So the rule of thumb, or the golden rule in this case, is avoid printing out any exception information other than that is relevant to the user. But don't just suppress the exception and do nothing. You should account for any method that is supposed to throw an exception. Then the actor that is interacting with it or with that method should handle the exception, and so on. Because not only are there revealing information in the exceptions themselves, in their names and in their message, it's also mainly the message that accompanies those exceptions that reveal often more information as well. And here is a helpful list of exceptions and some descriptions of the vulnerability that they expose if not handled correctly. So for example, if the program throws an SQL exception that just gets straight to the user, that might include some information to potential attackers about the database structure, username enumeration, and other vulnerable spots. And the insufficient resource exception indicates that you don't have a big enough server, so it might encourage DDoS attacks. And there are many more, so this is not a complete list, but just some examples.